In this video, I'm going to talk about application cost engineering. I'm going to break down exactly what that means, what the best engineering teams are already doing, and what you can implement for yourself. Because most engineering teams think they've already optimized their cloud costs, right? They've reserved instances, they've cleaned up all the idle resources, they've right-sized their compute, but the bill keeps growing and it's a little predictable. And that is simply because all the optimizations they've made live on the infrastructure layer. But that's not where most of the waste is happening anymore. What I'm trying to say is your cloud bill, the fastest growing part of your cloud bill, isn't on your servers anymore. It's on the code that's living on top of them, right? Every API call, every log line, every AI inference, that's application level spend, and almost nobody is optimizing for that deliberately anymore. So in order to do this properly, you need to adopt a few practices, and that's what we're going to talk about today. That is what we're naming application cost engineering. So really, ACE, or application cost engineering, I'm going to abbreviate from here on out. It's not a product or service, it's an engineering practice. Think like Scrum, test-driven development, continuous integration, that kind of thing. They're not products, they're engineering practices or ways of working that produce a better outcome. And ACE is the same thing. It's just really in line with what we've been seeing going on anyway. Like, consider how we used to do quality assurance. You'd build something, you'd throw it over the wall to the QA team, they would tinker, throw back a bug report, and you'd play this really inefficient, frustrating game of volleyball. And now we've got test-driven development, where you kind of get in and you implement those fixes on the build level. We saw security, the exact same thing. Instead of audits at the end, you would find code review while you were building. And this ACE framework is exactly the same thing, just applied to costs. What this looks like in practice is essentially the same as what we've already seen with regards to performance and security. So instead of optimizing for cost after everything's done and these decisions are already made, we're going to inject cost optimizations at 3 key points of development. The very first one being design and architecture. So before you write anything, you want to build a spreadsheet and model the cost characteristics of the system, okay? How many requests, how much data moves between the components, what scale factors are, what this looks like at 10x or 100x, so you have a clear idea as to what this looks like as you grow. Then model to choose your managed services. So let's take Kafka, for example. AWS MSK, MSK Serverless, and Confluent Cloud all do the same job, but their pricing structure is different. And the decision you make on year 1 might not be the right decision at year 10. So that's something that you need to think about in the architecture phase. And the second checkpoint is how you implement these sort of things. And you really need to think about cost variations the same, or degradations, the same way as you think about performance degradations, I should say. You need to write code efficiently for managed service, because every single one has their own cost traps and best practices. You need to do this from the start so you can see exactly what's driving costs once the code ships, right? Any regression should be caught as you build rather than a big surprise at the end. And the third checkpoint is operations and continuous optimizations. This is more of an ongoing thing, but it is absolutely essential as well. You need to monitor costs alongside latency and error rates as a continuous signal, right? Not just in the bill. So when anomalies appear, investigate while the code's still fresh. And as scale changes or new products come out, you need to reevaluate, right? What made sense at 1,000 requests per second doesn't make sense at 100,000 requests a second. Or if new services or pricing models come out, it's worth considering those, because they might be better for your service as time goes on. Really quickly before we move on, you can see if any of these are cropping up in your own code base by booking a demo at frugal.co. They'll go through the whole thing, see if there's any inefficiencies or if there's any of these cost traps popping up in your code. They'll show you what they are and exactly how to fix it. Again, that's frugal.co.